Hello everybody. In today's little mini lesson, we're going to be talking about angle of elevation and angle of depression. Now, firstly, we need to know what these things are. We use angle of elevation and depression whenever we're solving different trig problems, typically word problems. Now, angle of elevation is simply how much you look up. What's the angle change whenever you look up? Now, let's illustrate this. So we have some person, let's call it you, and you're looking straight out. Okay, this is your line of sight. Now if you tilt your head up, your line of sight is going towards the sky. This angle between where your line of sight was and where it ends up is your angle of elevation. Now the same concept is what angle of depression is as well. Instead of looking up, you're looking down. So imagine you're on a mountain. You're on a ledge or a mountain, and you're standing there looking out, and then you decide to look down at your family or friends below. The angle in the change of your line of sight from where it was to when you start to look down, this is your angle of depression. So whenever these words are mentioned in the word problems, you know what they are and you'll be able to label them properly. Because half the struggle with trig word problems is just drawing the proper picture and making sure everything is labeled in the right place. So let's go to this first word problem. Romeo approaches a tower, tilts his head up, and locks eyes with Juliet at an angle of elevation of 50 degrees. If Romeo is 6 foot tall and he knows that he is 300 feet away from the base of the tower, how high up the tower is Juliet? Okay, so we have some tower. We have some tower that Juliet's in. She's in it, and she's looking, and here Juliet is in the tower, and Romeo approaches the tower, and he is 300 feet away from her, and he locks eyes with her at an angle of elevation of 50 degrees. Okay, so let's kind of draw our picture, draw our triangle, and see what we can figure out. Okay. So we know that the angle of elevation is 50 degrees. And we know that Romeo is 6 feet tall. So how are we going to solve this problem? Now, I know my line of sight makes the height look like this short distance, but this side of the triangle is from Juliet to the ground. And we're looking for this unknown value, how high Juliet is off the ground. To solve these trig problems, we need to think back to SOHCAHTOA. We need to know which of our trigonometric functions to use. So what do we have in this illustration? Well, we're searching for our opposite side. Our x is our unknown. And then we're told that the distance we are away from the tower is 300 feet. So our adjacent side is known. So we're going to be using tangent as our trigonometric function. So we know that tangent of 50 degrees must be equal to our opposite, which is our unknown x, over our adjacent, which is 300. We can multiply both sides by 300 to solve for x to get that 300 times 50 degrees, times tangent of 50 degrees is equal to x. Now once we're here, we just plug it into our calculator. So we have 300 times the tangent of 50 degrees. And we see that Juliet is 357 feet above above the tower. So x is approximately 357. Excellent, excellent. Now, of course, my picture is not drawn to scale. Romeo being 6 foot tall, it looks like he's 100 feet tall in this picture. Picture not drawn to scale. All right, next problem. Let's look at another one. Two friends, Griffin and Sean, are standing on opposite sides of the Eiffel Tower. If Griffin is 5.8 feet and looks to the top of the tower with an angle of elevation of 42 degrees, and Sean is 6 feet and looks up to the tower at an angle of elevation of 54 degrees, how far apart are the two friends? Okay, so let's draw the Eiffel Tower here. So this can be the top, and then it comes down at some base. So let's have it look like this. And then we can say Griffin's on this side. And we can have Sean on this side. Now we're told that Sean is 6 feet tall. And we're told that Griffin is 5.8 feet tall. Now, what else are we told? We're told that Sean looks up at an angle of elevation of 54 degrees. And we're told that Griffin is looking up at a separate angle of elevation, and his angle of elevation is 42 degrees. So again, it's really important to draw these pictures correctly, so read carefully and label properly. Now, what do we need to do to solve for the distance between the two friends? Well, what we're going to have to do is we're going to have to find the unknown distance from the base of the tower for both friends, and then we need to add their distances together in order to find the total distance apart in which they are. So if Griffin is looking up to the tower, to the top of the tower, and we're told that the tower is 1,068 feet tall, how can we solve for the distance away from the base of the Eiffel Tower? Well, this is where the trigonometry comes in. Again, we need to think of SOHCAHTOA. And we need to think about which trigonometric function we're going to be using. Here, our opposite is known, and our adjacent is the unknown. So again, we're going to be using the tangent function, where the tangent of 42 degrees is equal to the height. Now, before you write 1068 for the height, what's the height going to be? It's going to be the height of the Eiffel Tower, 1068, minus the height of the person. In this case, 5.8 feet. So that's the distance. So be sure to subtract the height, and then that's all over our unknown x. So then whenever we solve for x, we can multiply both sides by x, then divide by tangent of 42 degrees to see that our unknown distance from the base of the tower is x equals 1068 minus 5.8. Here we can pull up our calculator. Just let's make sure we don't do any mental math incorrectly. 1068 minus 5.8. 1062.2. So this is 1062.2 over tangent of 42 degrees. So this is what Griffin's distance from the base of the Eiffel Tower is. Now let's find Sean's distance from the base of the Eiffel Tower. It's going to be the exact same process, just a little bit different numbers. So let's check it out. So Sean's distance, it's also going to be tangent. It's going to be tangent of 54 degrees. And it's going to equal the height of the Eiffel Tower minus his height of 6 feet to give us 1062. And then it will be divided by the distance away he is, which is some unknown y. Then we can solve for y the same way we solved for x, multiply both sides by y, then divide by the tangent of 54 to get that y is equal to some 1062 divided by tangent of 54 degrees. Now that we have the distance Sean is away from the tower and the distance Griffin is away from the tower, we can combine the two to find the total distance the boys are from one another. So let's pull out our calculator. Let's clear it all. So for Griffin, we have 1062.2, and then it is divided by tangent of 42 degrees. So 42 tangent function, enter. So 1179.7. So this is 1179.7. And then for Sean, here he is 1062 divided by tangent of 54 degrees. Which is 771. Now we're going to add Griffin's distance, which was 1179.7, to see that the boys are a total of 1951.3 feet away from each other. 1951.3 feet away from each other. Now, quick bonus question. How would this problem be different if the boys were on the same side of the tower instead of on opposite sides? Well, if the boys were on same side of the tower, we would end up subtracting their distances instead of adding them to find how close they were instead of how far apart in which they were. Excellent, excellent. Let's look at this next problem. 555 meters away from a tower stands this two-story house. If the person inside the house looks up from the second-story window with an angle of elevation of 44 degrees to see the top of the tower, and then down at an angle of depression of 18 degrees to see the bottom, how tall is the tower? Okay, this one's a little bit tricky. Feel free to pause the video and try to work it on your own. But let's go ahead and draw a picture. So we have some house, this two-story house, and so two-story house, and 555 meters away from the house is some tower. And what are we told? Well, we're told that somebody is in the house in the second-story window, and here, this red line can represent their line of sight. And what are we told? We're told that if they look up at an angle of elevation of 44 degrees, they can see the top of the tower. And if they look down at an angle of depression, then they can see the bottom of the tower. And now we are asked to solve for the total height of the tower. So we're told again that the angle of elevation is 44 degrees and the angle of depression is 18 degrees. So this is another two-step problem. Well, where first we're going to find this portion of the height of our tower, and then second we'll find the bottom portion of the height of our tower, and then we will add the two sums together to find the total height of the tower. Now again, we are told that we are 555 meters away from the tower. So we have, we're searching for our opposite side, and we have our adjacent. So we think to SOHCAHTOA. And again, we're going to be using our tangent function. For most of these angle of elevation and depression problems, you do use the tangent function. It's not always that way, but it typically, it often is. It often is. So firstly, in order to solve for x, what do we have? Here, let's scroll down a little bit, get some more room. We have that the tangent of 44 degrees must be equal to our opposite side, which is our unknown, over our adjacent side, which is 555. And then, so to solve for x is going to be equal to 555 times the tangent of 44 degrees. Then to solve for the bottom part of our tower, the bottom height, it will be the exact same process, just using this separate triangle, where the tangent of 18 degrees is going to be equal to the bottom portion, y, over 555. Opposite over adjacent. Then to solve for y, we'll just multiply 555 on both sides to get 555 times tangent of 18 is equal to y. Now we can plug both of these into our calculator, add them together, and get our answer. So let's pull open our calculator, clear it out. So firstly, for x, we have 555 times tangent of 44. That's 535.9. So we'll round up to 536. So this is approximately 536. And for y, we're going to do, again, pull up our calculator and clear it out. We have 555 times the tangent of 18. And that is 180. Again, we'll round. And then, of course, we need to add the two numbers together. So plus the 536 number to get a total height of the tower of 716 meters. Okay, that's a pretty tall tower, but 716 meters would be the total height. This next problem. A boat is traveling due east and the captain looks up at an angle of elevation of 30 degrees to see the top of the 250-foot lighthouse. 5 minutes later, the captain has to lift his head 40 degrees to see the top of the lighthouse. In feet per minute, how fast is the boat moving? Okay, so in some distance, out and about, there's a lighthouse. So we have a lighthouse. It's emitting this beautiful light. And a distance away, we have a boat. This can be our boat. And we have a captain steering our boat, commanding our boat. And he looks up at an angle of elevation of 30 degrees to see the top of the lighthouse. So he looks up to see the top of the lighthouse. Okay. So that's our line of sight. We know that the total height for the tower is 250. So let's label that. This angle of elevation was 30 degrees. Now what happens? Well, after 5 minutes of travel, the boat has continued to move. It's now here, let's say. And now the captain looks up to see the top of the tower, but instead of a 30-degree angle of elevation, it shifted to a 40-degree angle of elevation. And what's our final question? It says, in feet per minute, how fast is the boat moving? So what do we know? We know that it covered this distance in 5 minutes. So how are we going to solve this problem? Let's think about it. The boat traveled some unknown distance in 5 minutes. So we need to find out how far that distance was and then divide by 5 in order to get how many feet per minute the boat is traveling, to get the speed of the boat in feet per minute. So how are we going to figure out this distance traveled? Well, looking at our blue triangle, we can solve for this full distance between the boat and the lighthouse. And then looking at the red triangle, we can solve for the full distance between the boat and the lighthouse. And then we can subtract the two in order to get the difference in distance that the boat traveled. Then we can divide by the 5 to get the feet per minute. All right. So how are we going to solve this? Again, let's think to SOHCAHTOA. We have our opposite. We know that the tower is 250 feet tall. What we're looking for is our adjacent. So look at this, yet another tangent problem. So we have, for our first portion, for our blue, we have tangent of 30 degrees is equal to our opposite, 250, over our full distance of our unknown x. Then to solve for x, we can multiply both sides by x, then divide by tangent of 30 degrees to get that x equals 250 divided by tangent of 30. Now we can simply plug this into our calculator to get some value. Where'd my calculator go? Here it is. So my calculator, we're going to take 250 and divide by tangent of 30 degrees. And we get that we're a distance of 433 feet away. So this is approximately 433 feet. Now let's solve for our red triangle. To solve for our red triangle, it's also going to be tangent. It will be tangent of 40 degrees is equal to our opposite, 250, divided by our unknown distance. We'll call it y. To solve for y, we can multiply both sides by y, then divide by tangent of 40 degrees to get that y equals 250 divided by tangent of 40. And now we can plug this into the calculator to find our distance. So we pull up our calculator. We're going to clear this. And we have 250 divided by the tangent of 40 degrees. To see that we are now a distance of 298 feet. So this is a distance of 298 feet. Now, in order to find our feet per minute, we need to find our distance traveled, and we'll find that by taking 433 and subtracting 298 from it. Bottom number is bigger, so you borrow. We have a 5. Again, bottom number is bigger, borrow. 3. So we have 135 feet traveled in 5 minutes. So we take 135, divide by 5 to get 2, 3 left over, 7. So we are traveling at a speed of 27 feet per minute. It's a pretty slow moving boat, but there you have it. That's how you solve this problem. Here we have one more problem. Let's get it done. What do we have? We have Alicia is standing on a bridge 50 feet or 0.88 miles off of the ground. She looks up at an angle of elevation of 77 degrees to see a rocket ship which launched 4 miles away. How high in the sky is the rocket ship? Okay, so we have Alicia. She's standing on some bridge that is 0.008 miles in the air. And she is looking up, nearly straight up, not quite straight up, but she's looking up at an angle of elevation of 77 degrees. And what else are we told? We are told that 4 miles away, so we'll call this distance 4 miles, there was a rocket ship that was launched. And it's going up, it's going up, it's going up, 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 up. And we want to know how high the rocket ship is now. You know, now it'll be up here somewhere. So how can we find that height, that total height? Well, again, thanks SOHCAHTOA. And hey, look again, our opposite is our unknown, and our adjacent is known. That's 4. Opposite and adjacent is tangent in SOHCAHTOA. So we're going to use tangent function. So tangent of 77 degrees is equal to the unknown height, x, over 4 miles. Now to solve for x, we can simply multiply both sides by 4 to get 4 times the tangent of 77 degrees is equal to x. We plug this into our calculator. And we have 4 times the tangent of 77 degrees to get 17.3 miles. So 17, so this is approximately 17.3. Now, are we done here? Well, no, we're not quite done, because we were also told that Alicia is 0.008 miles above, she's on a bridge this tall. So we actually need to add that value to our answer. Okay? We need to add that value to our answer to get 17.308. So there we have it. That would be our true answer. If you're going to round it to the nearest tenth or something, the extra height didn't really make a difference, but it's best to add it just to be exact since it was part of the problem. All right, there we have it. I hope you learned quite a bit in these angle of elevation and depression problems. This boat one was probably my favorite, with finding the speed of the boat in feet per minute. It's quite fun. Now, again, the trick with all of these is simply to draw the picture properly. If you label everything properly, you're going to do great on all these problems. Some of the things I've seen students miss the most is with is mislabeling the angle of depression. So remember that angle of depression is just the angle change when you look down. That's what angle of depression is. If this video was helpful, give it a like, subscribe to the channel, and I'll see you in the next one.